Hello everyone, this is Max from PLC24. I'm going to use ArtCam 2011 to create a sample G-code and run it on my 3-axis CNC router with multiple tools. New project. Save as. Give it a name. I'm going to overwrite this. That should be fine. File, new model. This is going to be my workpiece is 36 inches by 16 inches MDF. Half-inch thickness. So I don't have the thickness here, but later on we have to define it. So okay, hit OK. Then let's add a few objects. Start with the circle. This one I'm gonna put center on 8 and 10.5 with the diameter of 5. Preview looks good. Select the select tool from here, go to top menu, block, copy, rotate, and then I'm going to rotate it 360 degree around this point, the bottom point, which is 8 by 8, right? Yeah, how many objects? 6 in total. So hit apply, close, and then let's make a small one here. It's gonna be a square, 3 by 3, sharp corner, center point. For this I'm gonna use 16 and then 4. Angle 0, preview, that's good. And then let's go back, first select it and go back to block, copy, rotate. This time block, copy, bottom to top. How many? 3 in total from this object, and gap 0 and X. I want to have it vertically with 1 inch gap between them. Apply. Looks good. Let's make a logo of Instagram. So it's a square, 7 by 7, corner, round corner 1 inches, center point, let's round it as 23.8, 23x and 8y, 0 angle, preview, looks good. Let's make another one, which is gonna be, that was 7, this is gonna be 5. Again, round corners, same point, center point, angle, preview, done. And then we need a circle. Let's make a diameter of 3. Center point is gonna be same as before, 23.8. Preview, done. Something is missing, a circle here. Let's make it half-inch. This maybe 24.5. Around this one 9 point. Oops, sorry. 9.75. Preview. Click. Looks good. Okay, we have some space here, so let's add triangle. Okay, after I created an object, we can change it. So instead of select tool, we use transform vectors. Then a window pops up Center point, I'm gonna have 13.5. Let's make it 6.75. And the dimension, uncheck width and height. So freely I can change it to 2.5 by 2.5. And apply. Looks good. Select tool again. And then let's make it 4 of them. Rotate. 4 of them. 360-degree again all around. And I'm gonna make it around this point, which I believe is 13.5 and 8. Close. Then this is pretty much of the object. Let's make a cutout. For the cutout, it's going to be a rectangle. And the width, let's put it 32 by 13. Height. Sharp corner again. Center point is going to be the middle of my workpiece. My workpiece is 36 by 16. So this is going to be 18 by 8. Angle 0 preview. Looks good. Alright, so now this is all lines. There is no tool path, nothing yet. So I drag a rectangle around these circles. Control G, I can group them or right click group vectors, but that's okay for now. I just select them all. Tool path, 2D tool path, profile. You have 3 options, outside, inside, align. Usually if you want to exact same dimension, you have to use outside. You see that here in this tiny picture, it's going to compensate the tool diameter. But for this one, I prefer along the lines. So it's going to go along these lines. The start depth is the top of my material. It's going to be 0. How deep? 1/4 inches. Tolerance, I don't touch it, default. Okay, which tool I'm going to use for this? Let's process it with ball nose. Again, I'll show you. Profiling tool, you can select it from by clicking on this tiny arrow. ArtCam has a big database of different tools. I go to inch tools, wood and plastic, and then for 3D finishing, the ball nose that I have on my machine is a metric one, 22 millimeter diameter ball nose. So I select that. Then I click on edit to take a look inside. The units which I'm using here is millimeter, and the diameter is 22. Step down, this is important too. Depends on the length of your, not the diameter, but the length of the tools, and also how deep is going to be your profile. My profile, remember that we put it 0.25 or something. So whatever above that, if you put here, it's going to process it in one pass. So if I put less than 25, it's going to make it in multi-pass, 2 or more. But I'm okay with one pass, so I leave it as it is. And for that was for the dimension and length. Also for the feed rate, how fast it's going to go and move in the workpiece, in the MDF that I have. I'm going to run it at 15,000 RPM revolution per minute for the spindle. Feed rate means that how fast it's going to move in the wood, in the MDF. 100 inches per minute looks good. And plunge rate, how fast it's going to go inside the work in first time. So everything looks good to me, yeah. And the tool number is important when you're deal with multiple tools. Tool number one in my machine is that ball nose. So everything looks good. You can add some notes, but that looks good for now. Click OK. Select. Tool is selected. You can open it up and see or change it here. And then we have two type of cutting, climb or conventional. There are many different, YouTube talking about that, but I prefer climb for now. You can have fancy movement to go inside the material, ramping. Usually we use it for harder material or have a better finish, but that's okay for me. I don't use them now because it's going to increase the processing time. So the other thing is the cutting sequence. You can have it manual or automatic. Automatic optimized ArtCam is going to decide which circle is going to process first and then next and then next. Safe Z is important here. I put half inch because when the first, for instance, first circle is done, it Z axis goes half inch above the surface and travel to the next and process it, goes down, process it, and goes half inch above the surface again and process it next. And after everything is done, it's going to go to the park position. It's a home position here, but it's different from the home machine home position. So it's a park position for me. 40, 20, and 2. And the material that I'm using is half inch MDF. And the bottom, the top of my material is 0. So I put it 0 here, okay. Everything is done. Just I need to give it a name. T1, ball nose, and calculate now. And you can see on this window, under the toolpath is already added here. So you can even edit it and give it a name. For instance, I want to say ball nose circles. Oops, it made a copy, so let's delete that one. And we make sure, we double click on that, we make sure that it didn't mess up anything. Yeah, everything looks good. Yeah. Then I'm gonna pocket these 3 squares. So it's gonna raster, it's gonna go back and forth with the end mill tool inside these 3 squares. I select them all again. Toolpath, 2D, area clearance. Start depth 0, finish depth. 0.2 is enough. Tolerance and these allowance and final allowance, we don't change it. Again, this is some feature you can use and later on I'll explain in another video, but for now I'm okay with that. So for tool, let's select the tool. You can have multiple tools for pocketing, but I'm gonna use only one bit for this, which is the end mill with the 6mm diameter. Edit. This is gonna be tool number 2, and because it's metrics, 6mm diameter, and a step down, we already talked about that, so everything looks good. We don't change these things either. Just check the tool number 2, that's okay, and select. So it's added here. You can edit it here. I prefer to have it as raster instead of offset round pocketing. Material shouldn't change. No, that's okay. Just give it a name, T2 and mill 6mm pocket. Calculate now. Close it. Now let's select these three. For selecting multiple objects, you can press and hold the Shift key and click, click, click. These three are selected. Toolpath, 2D, profile. For this one also, I go align the lines. Start 0, finish 25. Tolerance, don't touch it. Okay, for this I'm gonna use a V curve. And obviously it's gonna be a different tool number. So I select this one and then make sure that, yeah, it's tool number 3. And it's a metric 22mm diameter of the V curve with a 90°. We have different types of V curve bits. So make sure to choose the appropriate one. And I don't change anything else. Hit OK, select, and give it a name, T3 Instagram. Looks like Instagram, right? Insta. That's okay. Calculate. Oh, let's add a V curve here. Curve 22mm. So calculate now. Close. How about this one? We're gonna drill it down. So select it, tool path, 2D drilling. Finish with, we don't want to go all the way, so 0.4 should be fine. 2. ArtCam doesn't have the drill bit category, so I created a new group here. You can add a new group by simply just click on here and give it a name. And then inside that you can add a tool, define the tool, or just copy from the existing one and bring it here. Which I already did that here, so let's edit that, make sure everything looks fine. Click on edit. Tool number 4, yes. Diameter 6, yes. Everything looks good. 12,000 RPM looks good for drilling, so okay. Select. This is selected. I don't want to have like packing drilling. Optimize is good. Material, same. T4 drill 6mm. Calculate now. And let's select this 4. For this also I'm going to use V curve. So profile. And this time let's go outside. So we're going to have exact 2.5 by 2.5 inches for those 4 triangles. Start depth. It's going to be 0. Finish depth 20. By the way, it depends when I say exact, because if you use the end mill, just like a straight bit, since I'm gonna use a V curve, to be honest, it's not gonna make any difference if I go along or outside. It depends on your drawing or what you need, right? But for now, it's just a test, so let's use that. Select the tool, V curve. Tool number 3, same tool, yeah. No fancy movement. this hasn't changed, so just give it a name T3 annual. And 6 millimeter triangles. Calculate now. 1, 2, 3, 4, 5. Oh, we cut out. Select it. Profile. Profile. For this one, we use the outside. And since I'm gonna use an end mill, which is a straight end mill 6, it's gonna give us exact dimension that we're gonna have here. So select it and finish depth. Start depth 0, finish depth. Material is 1/2 inch, so let's go a little bit deeper to make sure that it's gonna cut it out. It's not gonna damage my bed, the CNC's bed, because I have something underneath. I mean, between my workpiece, actual workpiece, and the table. That should be fine. Yeah. Give it a name. T2 and meal. Cut out. Oh, I just noticed a mistake. It's not a big mistake, just you see here, tool number 3 is a V curve, so edit or rename. And meal no V curve. Should be fine. Yeah. So it's all created 1, 2, 3, 4, 5, 6 tool path. And now let's create the G code. But before that, we can simulate that. Right click on tool path, simulate all tool path. Default is good. Customs for the resolution 100 and hit OK. Here we go. Looks good. You can zoom in, zoom out. You can play with these things to have a better look, but for now it's okay for our purpose. Right click on toolpath and let's save it as a G code. You can access it from here or from here. Save toolpath as. So save toolpath as, and we have two windows. Whatever we have on the left side is whatever we have on the drawing, the toolpath that we created, all those that we created. But on the right side window is what we're gonna put on the G code in order. So order matters here. First, let's make the drilling one, and then second, we're gonna have the pocket one. Which one was that? It's this one. Tool number 2. This is what the description helps you to decide which one is which one. And then let's make the cut out is going to be the last one. So we have to make it like after the pocket. Let's make the V carve one, the triangle, and then the insta one, and the ball nose, the circles here, and then the cut out is the last one. And before saving, make sure that you choose the right post processor. Post processor is a fancy name for because it's a fancy name for this option here. Basically, what it does is gonna translate all those tool paths and create the G code to translate those to the G code. So it's if you open up the this menu, it's a huge list of different controller like Siemens, I don't know, G-Fanuc, Fagor. The controller on our CNC is a Mark III ATC. So, and it's inches. So I'm going to use this. And then save. And let's overwrite this. Should be fine. Just give it a name, because when you save it, make sure that where you're going to save it. I'm going to use it. I'm going to save it in the same location in ArtCam file in the toolpath. And by the way, extension for this is going to be TAP, which is um, one of the extensions that the G code can use. The other one is like TXT, NC, different types. It's one of, there are a few, but TAP is good. And it's the only one that we can create actually here, so that should be fine. So we already created that. We close everything and we're done here. Let's load the G code on the controller and process it on actual workpiece. All right, we're gonna run that G code. Load the G code from Mach 3. Then we go to the toolpath sample. By the way, the machine is already home and Z height is adjusted. Also, I've already set my tool offsets here for the tool number 1, 2, 3, 4 that I'm using. So everything looks good. Then we started. Since I'm using a manual auto tool change here, I wrote this program, so it's gonna ask to change to tool number 4. So we click on yes, and axis move to near to the tool change position, and then we have to manually remove tool number 3 and put tool number 4, which we do, and then say yes, hit on OK, and it's get a confirmation again, and it's gonna process our first profile, which is that just one hole with the drilling, and that's done. Then we have to move put the tool number 2. It goes to the tool change position. Remove 4, put tool number 2, and then after we're done, we say yes, and it moves back and starts doing that pocket. Let's keep going. We can increase the feed rate to move faster. And this is the absolute coordinate and work coordinate here. The absolute coordinate is related to the work, the machine home position or the machine sensors. And the work coordinate, we can zero it whenever we want and wherever we want before running the program. I made a zero here in this point, which is compatible to our drawing. So it's almost done with the pocketing. Yeah, that's done. Now we need tool number 3. So it's gonna go to the tool, change position again. And remove tool number 2, put tool number 3, which is a V-carve one. Yes, yes. So the V-carve is those triangles outside the lines profiling, and this one, this squares along the vector. So now this is done. We need to do the ball nose one, so say yes. That's going to be tool number 1. And you can see in the code it's M6T1, which means it's asking for tool number 1. So basically this is a semi-automatic go to tool change system in our machine. Now that we put tool number 1, it's going to go and process those circles. And after this, the only things remain is the cut out. Also, I'll show you in the real video of the processing on the CNC. So now that's done. We're gonna make the cut out with the end mill with tool number 2. So yes, it's going to same position. So we can put the tool number 2 comfortably. And yes, okay. And remember, the cut out is going to be 2 passes because the depth is more than a step over. The cutting depth is more than a step. Cutting depth is almost half an inch. Step over is 25 or something, 0.25. So I'm not sure it's going to be 2 or 3. Yeah, 3. So I'm going to change the G code again and then make it with 2 passes for the cut out. And also I take some video of the machine that is cutting the new G code, which is same as this one with a few changes. 2.